What if I told you there's a way to store energy? Without batteries, without fuel, and without relying on sunlight or wind. And yet, most homeowners have never even heard of it. While energy bills keep rising and blackouts become more frequent, one of the most efficient energy storage methods has remained almost completely unknown outside of engineering circles. So, the real question is, why? Energy independence is no longer a fringe idea. It's becoming a necessity. Across the United States, homeowners are facing a combination of rising electricity costs, grid instability, and increasing concern about what happens when the power suddenly goes out. Naturally, people start looking for solutions: solar panels, generators, backup batteries. But what most don't realize is that there's an entirely different category of energy technology, one that doesn't rely on weather, chemical storage, or constant fuel input. In this video, we're going to break down the science behind flywheel energy generation, how it works, why it's so efficient, and what most people misunderstand about it. And more importantly, whether it could realistically play a role in how homes generate and store power in the future. Let's start with a simple truth. Generating energy is only half the problem. Storing it is where things get complicated. Most homeowners exploring alternative energy eventually run into the same issue: storage limitations. For example, solar panels can generate power during the day. But what happens at night? That's where batteries come in. But batteries have problems. They degrade over time. They're expensive to replace. They lose efficiency. And they rely on chemical reactions that are sensitive to temperature and usage cycles. Generators solve a different problem, but introduce new ones: fuel dependency, noise, maintenance, carbon emissions. So while these systems work, they're not exactly elegant solutions, which leads to an important question. Is there a way to store energy that avoids chemical degradation, fuel reliance, and environmental limitations? At its core, flywheel energy storage is surprisingly simple. It's based on a principle you've seen before, just not in this context. Imagine spinning a heavy wheel. Once it's in motion, it wants to keep spinning. That spinning motion, called rotational kinetic energy, can be stored and later converted back into electricity. Here's how it works in practical terms. 1. Electricity is used to spin a rotor, the flywheel, at very high speeds. 2. The system maintains that rotation with minimal energy loss. 3. When energy is needed, the spinning motion drives a generator. 4. That generator converts the kinetic energy back into electricity. No fuel, no chemical reactions, just motion and physics. And that simplicity is exactly what makes it so powerful. But here's where things get interesting. One of the biggest advantages of flywheel systems is efficiency. Traditional batteries lose energy during charging and discharging. Flywheels, on the other hand, can achieve extremely high round-trip efficiency, often exceeding 85–90% in optimized systems. Why? Because there's no chemical conversion. It's purely mechanical and electrical. Modern flywheel systems also use magnetic bearings to reduce friction, vacuum enclosures to eliminate air resistance, advanced materials that allow higher rotational speeds. The result? A system that can store energy with minimal loss over short to medium time frames. But efficiency alone isn't the full story. Because the real question most homeowners care about is, can this actually be practical? Flywheel systems sound almost perfect, but they're not without challenges. And this is where many explanations fall short. First, flywheels are typically better suited for short-term energy storage. They excel at stabilizing power supply, handling quick energy fluctuations, providing backup for short durations, but they are not traditionally used for long-term storage like batteries. Second, High-speed flywheels require precise engineering. If not designed correctly, issues like imbalance or material stress can become serious concerns. Third, historically, flywheel systems have been expensive, industrial scale, complex to install, which is why they've been used more in data centers, grid stabilization systems, aerospace and research environments, not in everyday homes. So, if that's the case, why are we suddenly hearing more about them now? In recent years, something important has shifted. Advancements in materials, science, compact design, and manufacturing have started to reduce the barriers that once made flywheel systems inaccessible. Engineers have been experimenting with smaller-scale systems, modular designs, simplified mechanical structures. The goal? To make kinetic energy storage more practical outside of large industrial environments. And while most people still associate energy independence with solar panels and battery banks, there's growing interest in alternative systems that require fewer components, have lower long-term maintenance. Don't rely on weather conditions, which raises an interesting possibility. Could a simplified version of this technology be adapted for everyday use? One of the biggest barriers isn't technology, it's perception. Most homeowners assume, if I haven't heard of it, it must not work. If it's not mainstream, it's probably too complex. If it's mechanical, it's harder to maintain. But these assumptions aren't always accurate. In reality, mechanical systems can often be more durable than chemical ones. Simpler designs can reduce failure points, and alternative approaches can sometimes solve problems more directly. The challenge is that these systems are rarely explained in a way that feels accessible. So people default to what they already know, even if it's not ideal. So what have we really learned here? Flywheel energy generation isn't new. It's based on fundamental physics that's been understood for decades. But what's changing is how that physics is being applied. Instead of large industrial systems, there's a shift toward smaller, more adaptable solutions. And when you step back, a pattern starts to emerge. Most energy problems aren't about lack of power. They're about inefficiency, dependency, and storage limitations. Which means the real opportunity isn't just generating more energy, it's rethinking how we store and use it. Now, here's something worth thinking about. If energy could be stored mechanically, without fuel, without degradation, and without relying on the grid, what would that change for the average home? Would it reduce dependence on utility companies? Would it make backup power more accessible? Or would it simply shift how people think about energy altogether? There are already systems being developed that attempt to simplify this concept, making it more practical, more affordable, and more approachable for everyday use. If you found this insight helpful, subscribe to the channel for more practical energy solutions and step-by-step guides. But the real question isn't whether the science works. It's whether people are ready to understand it. If this topic caught your attention, take a closer look at how these systems are being adapted today. And more importantly, ask yourself, are you storing energy the best way possible, or just the most familiar way? Let me know your thoughts in the comments.